I'm Phil, and today we're going to continue with our motor projects in our seniors robot course. Looking at the projects, motor drive and projects, we've done quite a few already, and we're now down to looking at the H-Bridge, and we'll just move down. And our objective, we'll just include that. We'll have a look at what's on our desktop today. We've got a station computer from M5Stack, and that's sitting on a Fisher Technique baseboard with a Fisher Technique motor on the left. Okay, so here's our station computer on the top, and on the bottom of it, we've got a rotary sensor, which is really a potentiometer. And under that, we've got the H-Bridge drive unit, which has a capacitor on the bottom right. And the LCD on our H-Bridge station shows the current, the voltage, the pot for potentiometer, and the current movement status. And under that, we've got 3 buttons with a prompt. So button A is forward, button B is reverse, and button C is stop. And here's our H-Bridge drive. And we're going to drive this motor, which is also from Fisher Technique. It's a XM motor. Okay, so that's our desktop. See if there's anything else we have to. Yeah, we're going to also compare the speeds, and we're using a tachometer for doing that. Okay, so the objective is, I'll open that up. We're going to demonstrate the H-Bridge unit with a M5 station computer. We're going to show the parameters on the computer's LCD, that is the movement, forward, reverse, and stop. We're also going to show the electrical parameters of voltage and current. And we'll use the computer's buttons to change direction, forward and reverse, button A, button B, and button C to stop it. Hardware. From M5Stack, we're using the M5 station computer, and it looks like this. And what I like about it is that it's got lots of ports on it. So while it's a bit expensive, there's a lot of resources on board. You've got 6 grove ports, 2 for A, 2 for B, and 2 for C. There's a battery. The LCD, while it's small, is still adequate for the projects that I'm working on. And this is what it looks like from the top view. And the price of that is not quite double the price of an M5 core computer, but it is a lot more expensive. But you do get a lot of value for that additional cost. In addition, we've got the unit, which is the H-Bridge drive unit, and you need to add a capacitor to that. There's the angle sensor, which is just a rotary potentiometer, and that just goes into one of the GPIO ports. And we need Grove cables. From Fisher Technique, we're using the XM motor, a base plate, wiring, and some support blocks, and a little bit of Lego. Software-wise, we're using UI Flow 2, which you can get from the M5Stack website. First thing we do is paint the screen, and this is what it's going to look like. And the resources, we switch on the H-Bridge unit, and that gives us access to the additional APIs for the H-Bridge unit. And the code for this is here. So we might actually bring that down, just zoom down a bit so you can see the whole code in one go, and I'll bring that across. So this is the code for my very simple program. It has two main loops. There's setup, which is only goes through once, initializing the I to C port, sets up the angle and the address for the H-bridge, and sets the initial direction to stop, and the sets up the maximum angle. While we're measuring the current in milliamps, we're using arbitrary units for our voltage. On loop, we just simply set the parameters to the device measurements, and we then look at the motor current and set that to the label, motor voltage, and the angle. And we can change the behavior of the motor by pressing the buttons. So the events pressing button A, B, and C are on the lower left. And the code, while it's very simple, it's an effective way to demonstrate the H-bridge unit. Okay, so it worked, and I was happy with the results, and we achieved all the objectives. We demonstrated the H-bridge unit, showed the parameters on the LCD, and we used the M5Stack buttons to control the direction of the motor, and we were also able to stop it. We used the computer buttons for changing the direction, and we made a video. Our next project will be a tachometer using the line follower sensor to measure the speed of the motor. In this demonstration, we have a M5Stack computer called the M5 Station, which is just here, and it's coupled to a H-bridge unit, which is driving the Fishertech motor, which is a XM motor. And over here we have the rotary or angle, which is also a potentiometer, and that's our speed control. So we might do a demonstration of that. We look at the display on the station computer. We have the motor parameters, the current and the voltage on the motor. We also show the value of the potentiometer and the current status of movement. And if we wanted to go forward, we just simply press button A, and our motor will go forward. And we can change the direction by going reverse, and it will go the other way, and we can stop the motor. And that's the movements of our motor control using the H-bridge unit from M5Stack.